with that, I'm happy to take any questions.
We have time for like one quick question. Okay, these two questions.
Hi, really nice talk. I have a really quick question. I know in one of your slides you mentioned about using some pre-trained models like AlexNet, etc. And I was wondering if you have any thoughts on using trained models on astronomical images instead of the more terrestrial image feature extraction, and if you see that as being useful for your sort of work afterwards in terms of transfer learning.
So you're recommending using doing fine tuning, you taking models that have been pre-trained?
Pre-trained on specifically, multi-band imaging in Astro. I know there's a couple that did, for example, galaxy morphology classifications, which in principle learn more relevant features when compared to terrestrial imaging-based trained models.
Yes, this is something I consider. In fact, when I had considered this, I found in the literature research to show that actually you can improve classification of astronomical sources if you fine-tune a model that was trained with objects of cats, dogs, trains, cars, which is bizarre. How can this pre-trained model on everyday objects, how can you fine-tune it and it gives you better performance on extragalactic objects? So that's something I had considered, but ultimately, given the rarity of these objects and that there have been no models that are after these, the diffuse like Lyman alpha high redshift blobs, I decided not to pursue it. But again, I mean, I think it would work. I wouldn't be surprised.
Hi, I just have a very quick question. So earlier you mentioned you used multi-band information in CNN. So you showed G and R, and you also mentioned using G minus R can improve the classification. But why is that? You said you already used multi-band. Why using a
So
different scan?
again, in practice, a deep learning approach like this would learn that color characteristic. But what I was finding is these, with such a limited sample size, the training set had 2,000 instances. I couldn't let it train to 100 epochs. I couldn't let it train to 1,000 epochs. It would just start to overfit. I had to train at most 10 epochs. In fact, the final model only trained to 7. So, I mean, this was purely empirical. I found that by adding and very, very explicit, this is what I want you to learn, actually stabilize the training. And I think this echoes what the first speaker yesterday said, is if you're looking for lensing in images, perhaps it's best to black out the central galaxy because you're looking for the arcs. So I think this is an example of just giving the CNN information that you know that it needs to learn.
Let's thank